We established periodicity is a tendency to occur at regular intervals. In terms of elements in the periodic table, there are periodic trends in chemical characteristics. So whether things tend to be chemical and physical characteristics, whether they tend to be solids at room temperature or gases, whether they tend to be reactive or non-reactive, whether they tend to be conductive or non-conductive, those tend to occur periodically, and they tend to occur lined up with the groups. So I want to just review this real quick, because this is going to become real important. A shell is an energy level. That's things like n equals 1, n equals 2, etc. Subshells. 2p is a subshell. 2p is not an orbital. 3d is a subshell. 3d is not an orbital. 3d1 is an orbital. 3d5 is an orbital. 3d is an orbital. Okay? So 2px is an individual orbital.
Yeah, I think you said 3D is an orbital.
3D is not an orbital.
Yeah.
Sorry, 3D is a subshell. 3D is, oh good, you guys got it straight even if I don't. Okay. Well, that's number of, here we're not talking about numbers. We're just talking about the terminology. So, n squared is the number of n squared is the number of actual orbitals available. Okay. And then you get your individual orbitals. So that becomes important because we're going to start to talk a whole lot about filling up subshells and filling up orbitals. Yes, sir? Because 3s doesn't, the s subshells don't get a designation because there's only one orbital in an s subshell. So 1s is both a subshell and an individual orbital. Yeah. Okay. So I'd like you to take your table of all the things in the universe that you've ever touched or tasted or walked on or sat on or brushed up against or petted or looked at fondly. And I'd like to draw your attention to hydrogen up here at the top. Hydrogen. Okay. Hydrogen. So, if you would take a look at hydrogen, the hydrogen that sits above lithium, and go across to the hydrogen that's sitting above fluorine, and I would like you to put a light X. Don't like scribble, scribble, scribble. Just put an X through that other hydrogen that's sitting above fluorine. We'll talk about why that is in a minute. It has to do with Clay's apples. They don't quite fit in where they think they ought to. Okay. So, if we look at that first period, remember, groups run up and down, periods run horizontally, periods are rows. If you look at that first period, we have hydrogen and helium in it. So how many things are in that first group, or that first period? 2, ghosts, side. Okay. So I'd like you to go down to the second period. How many elements are in that period? 8. No. 2, 8. Seems I've heard those numbers before. Okay, I'd like to go down to the third period and count how many things are in there. 8. Huh. Okay, well, never mind. That blows my pattern. That blows the idea I had. 2, 8, 8. Let's look at the next one. How many are in there? 18. 18. That number sounds so familiar. 2, 8, 8. I feel like I should know this. Okay. I love the light bulb. I love the light bulb. So, the length of each period is all based, as it turns out, on what subshells you're filling. So if we have something with 1 electron, where does that electron go? It goes into an s orbital. Which s orbital? 1s. So, hydrogen? Really? 1 electron in a little 1s orbital. It's kind of lonely. If we give that electron a friend to play with, If we have 2 electrons, where's that second electron going to go? Also going to go into the 1s orbital, and now we have what electron configuration? 1s2. And guess what? We're done with that period, and that energy level is full. Oh my God, how cool!
Well, why didn't you add it?
We're going to talk about that. We're going to talk about that. Pretend that second hydrogen doesn't exist. We're getting to why hydrogen is such a problem child. Okay, so let's imagine we now have 3 electrons. We'll go to lithium. Where do the first 2 electrons go? 1s, and we're full. We have 1s2. Where does the next electron go? 2s. So we have 2s1, right? Well then, we add another electron. It goes into 2s, so now we have 1s2, 2s2. How many atoms, how many elements do we have between aluminum, or between boron and neon? 6. So what do we fill after 2s? How many electrons can we put into P? Huh. It's almost like those things are connected. Okay, we're gonna back up. Almost like those things are connected. We're gonna do this like 6 different ways. We're gonna explain the same thing 6 different ways. Whoa. So on that second period, we're filling the second main energy level. How many electrons? So think back to that old Bohr model where we don't have a whole lot of details. How many electrons can the second main energy level hold? 8. How many elements are there in the second period? And where are we putting all of the electrons in them? The second main energy level. Huh. Interesting. It's okay, like I said, we're going to do this 6 different ways. Okay. How long a given, how many elements are in a period is all down to what subshells we're filling. Those go into the 6th and 7th periods. You're going to see how that makes sense in a second. Okay, here's the cool part. This is going to simplify writing electron configurations tremendously. Whatever period you're in, that number is the same as the highest occupied main energy level. So, period 1, helium. What's the highest main occupied energy level for helium? 1. Main level. What period is helium in? 1. Yeah. 18. Okay. Let's look at, so quickly on your paper, write down the electron configuration notation for carbon. 6 electrons. You're trying the neon yellow thing. Yeah, 3 of you show up in that color for one day. That's often how I get dressed too. Okay. So, what's the highest occupied main energy level in carbon? Somebody in red or pink? Yeah, 2. It's got electrons on the second main energy level. You would all agree with this? It's in what period? 2. So, draw your attention to iodine. Symbol I, atomic number 53. What period is iodine in? Jot it down, compare notes with a neighbor. Iodine, 53. So what period is it in? Remember, periods are your rows going across. Okay, hold up fingers. What do you think is the highest occupied main energy level for iodine? 5. This is handy, isn't it? It's going to tie it. You are noble gas notation is going to be so fast for you now. In about 15 minutes, you're going to be able to do noble gas notation in 3 seconds without thinking.
That's good.
It was a pain in the butt. It is going to be so fast and so easy. Okay. So, I'm going to pause this. Before I do that, this is where we're going to get out the colored pencils